All right, today we're going to crack the code on a really interesting GCSE maths problem. This one's a bit of a beast, actually. It mixes indices with simultaneous equations. So yeah, let's just dive right in.
Okay, first thing you've got to notice is this little symbol right here. This whole question is non-calculator. What does that mean for you? Well, it means this is a pure test of your algebra skills and how well you really know those laws of indices. No shortcuts.
So here's the problem in all its glory. You've got two bits of info to work with. First, this pretty complex-looking equation with all those exponents. And second, a much friendlier-looking one, x plus y equals 8. Our job? Use both of them to figure out exactly what x and y are.
Okay, here's how we're going to tackle this. We'll start with the problem itself. Look at the examiner's blueprint, then go through the three main steps. Unify the base, form the equations, and solve for x and y. And then we'll put it all together for that full mark answer.
Right, let's talk about the examiner's blueprint and how those marks are actually awarded. You know, to get top marks, you've got to think like the person who's marking your paper. It's not just about the final answer, it's all about showing the process.
So this mark scheme is basically our roadmap to success. And look closely, it's not all about getting x and y right at the end. See these P marks? You get 3 of them just for showing you've got the right process down. Then the 2 A marks are for accuracy. Our mission is to tick off every single one of these. Let's do it.
Okay, step 1, unifying the base. We need to get everything into powers of 3. Now, the real secret to cracking that first equation is spotting that all those numbers, 9, 27, and 243, they all speak the same language, and that language is powers of 3. Why does that matter so much? Well, once the base numbers are the same, we can just focus on their exponents. It makes everything way simpler.
So here's that equation again. Yep, looks a little scary, but trust me, once we translate it into our base 3 language, it gets a whole lot easier to handle.
Okay, watch this. We know 9 is just 3 squared, right? And 27 is 3 cubed. The one you might have to think about for a second is 243, but that's 3 to the power of 5. So when we rewrite the equation like this, boom, all the base numbers are the same. That is the absolute key first step. And check this out. Just by doing that, just by making that one conversion, we've already hit the first checkpoint. That's our first process mark, P1, in the bag. Easy as that. We are officially on the scoreboard.
Alrighty, on to step 2, forming the equations. Now that all our base numbers are 3, we can we can basically ignore them for a minute and just focus on the exponents. This is the magic trick that turns a nasty indices problem into a much more familiar algebra problem. So let's simplify those exponents. Remember your laws of indices? A power raised to another power, you multiply them. So 3 squared to the power of x becomes 3 to the power of 2x. And 3 cubed to the power of y over 2 becomes 3 to the power of 1.5y. And since we were multiplying the original bits, we now get to add those new exponents together. And here's the best part. If 3 to the power of something equals 3 to the power of 5, well, that something has to equal 5, doesn't it? And just like that, we have our first real equation, 2x plus 1.5y equals 5. And guess what? That's our second process mark locked in. So look at what we've done. We've taken that really messy indices problem and boiled it down to this, a pair of simultaneous equations. Now, this is something we know how to deal with. We're on much more solid ground now.
Okay, step 3. Let's solve for x and y. This is the final calculation. We've got our 2 equations, now we just need to solve them. This is where we pick up our third and final process mark.
The substitution method is going to be our best friend here. So, first, let's take that simpler second equation, x plus y equals 8, and just rearrange it a bit to get y equals 8 minus x. Easy enough? Now, we take that value for y and we plug it or substitute it right into our first equation. Okay, now we expand those brackets and simplify. Let's get the like terms together, so 2x minus 1.5x, that leaves us with 0.5x. And boom, we're ready to solve for x.
So if half of x is -7, well, that means a whole x has got to be -14. And there you have it. That's our first solution and, more importantly, our first accuracy mark. Nice.
But we're not done yet. We've got x, now we need y. So we take that x value, -14, and we pop it right back into that handy rearranged equation we made earlier, y equals 8 minus x.
Now, be super careful with the double negative here, right? 8 minus -14 is really 8 plus 14, and that gives us 22. And that's it, our second solution and our final accuracy mark. All marks collected.
So let's put it all together and look at the 4-mark answer. If you step back for a second, you can see how we just followed that blueprint from the mark scheme, building our answer one piece at a time.
And there they are, our two final answers, side by side. We found the one single pair of numbers that makes both of those original equations true.
It's also worth pointing out these little letters here, CAO. That stands for Correct Answer Only. It's basically the examiner telling you that for these accuracy marks, you have to get these exact values. Being close isn't good enough, and you have to have shown valid working to get there.
So that leaves us with a really interesting question, doesn't it? What's more important, knowing the formulas or knowing the process the examiner actually wants to see? You know, in a question like this, it's not enough to just know the rules of indices. The top marks, the full marks, they go to the people who can show that logical process, step by step. Knowing what they're looking for, well, that's half the battle right there.